All right, let's look at the precise definition of an infinite limit. All right, so here's the definition. All right, so limit of f of x as x approaches a is equal to infinity. So it goes to infinity. All right, if right for all some big number m greater than 0, there exists some epsilon, small enough epsilon, such that, right, so as long as distance between x and a is less than epsilon, right, of course we have to eliminate the case where x equals a. This guarantees or implies that f of x value can be made bigger than any big number m. Right? So this is what it looks like. Right? So let's say you have a function f. The graph of function f looks like that. Right? Let's say somebody gives you a fairly big number m. So I'm going to just put the m right here. So here's the value m. Right? So here is m. Right? Then if you can see that, no matter how big m is, we can always find the delta small enough. For example, delta could be like this much and this way. So you have this delta here. So it's a minus delta is right here. And here is a plus delta, right? If you keep x within this range between a plus delta, almost missed it, and here, sorry, it doesn't look very even. All right, but you can see that if x stays within this range, you can see that the graph is going to always stay above that given m. And if we can do this process for all possible m, we know that the limit is going to go to infinity because we can make the function as big as we wish. Right? So let's use this definition to prove this following limit statement. Right? So limit of 1 over quantity x minus 1 squared as x approaches 1 is going to infinity. Right? So somehow we have to find the delta in terms of m, right? So here's what I will usually do. I'll do a scratch work, right? So this is not the part of the proof. So I'm going to do a scratch work here. So here is my scratch work. All right, so scratch work goes like this. So you have f of x is sitting right here. So this is my f of x. All right, I'm going to kind of go backward. So what we want at the end is f of x is greater than m. So we're going to start with what we want. So f of x, so maybe I should put that in already. 1 over quantity x minus 1 squared. So we want this guy to be bigger than m, right? Then I'm going to keep writing it. So this is equivalent to, right? I'm going to take the reciprocal of both sides so that, it looks upside down. So we take the upside down. So you have x minus 1 squared and a 1 over m, right? And one thing we have to be worried about is when you take the reciprocal, the direction of the inequality has to be reversed. So I have to do that. All right. Then remember that we are interested in x minus a. A in this case is 1. So this a is 1. So we're interested in getting absolute value of x minus 1. All right. So we can actually get that by taking the square root. All right, so this is equivalent to taking a square root. Right? So if you take the square root of x minus 1 squared, we get the absolute value of x minus 1. The reason why it's absolute value is that since it's already got squared, it's never negative. So if you take the square root, it's going to be always a positive value. All right, so then you have square root of 1 over m. And the direction of the inequality does not change. Right? So you can see that we're looking for the delta value. So this is going to be our delta value. All right, so that's enough for scratch work. So here's the proof part. All right, so you can erase it if you want, as long once you know this expression. All right, so we did this. So here's the proof. All right, so we say for all m greater than 0. The reason why we know that there exists a corresponding delta is that we have a formula for it. All you have to do is somebody gives you an m, you take the reciprocal and then take the square root. So we just figured that out from the scratch work. Right, so we have that. We know that this is going to be positive, right? So we have. All right, so such that. All right, so we have, if we make sure that this particular delta, so we have x minus 1 less than delta, which is a square root of 1 over m, right? We know that this implies, right? So here we just kind of go backward on this, right? So I'm going to squared both sides. So you have, if you square that, you get quantity x minus 1 squared. And we don't really need the absolute value because it's getting squared, so you don't get negative value, right? And then as it's still less than, and if you square that, square root is gone, so you have 1 over m, right? Then after that, we take the reciprocal, so we're really just going backward, right? If you take the reciprocal, so you have a 1 over quantity x minus 1 squared is less than m. Actually, I messed that up, right? When you take the reciprocal, we just have to change the direction. All right, which is exactly, this is f of x is greater than m, right? So this proves that the limit of 1 over quantity x minus 1 squared as x approaches 1 is going to be equal to infinity. All right, that's it. I hope that this was clear.